This is Lesson 12, Solutions to Linear Equations. And this is Activity 2, Apples and Oranges. And we're going to use this word solutions quite a bit as we go through this activity. This is an important idea throughout this lesson. So we're going to look at the cost of apples and the cost of oranges and see how we can combine the number of apples at a cost of $1 per apple and the numbers of oranges at a cost of $2 per orange, make a different combination of purchases of numbers of apples and numbers of oranges. So in the first case, 6 apples, 3 oranges, 4 apples, 4 oranges, and so on down this list. Well, to keep track of it, I'm going to make a little table here. It's $1 for each apple. So I'm going to multiply the number of apples times $1. I'm going to multiply the number of oranges times $2. So 6 apples, that's $6. 3 oranges, that's also $6 because 3 times $2 per orange is $6. Add them together, you get $12. And then for the rest of this, it's the same idea. 4 apples times $1 each, 5 apples times $1 each, 8 apples times $1 each, 4 times 2, 4 times 2, and 2 times 2. Add them all together and you get the total cost. So imagine you're going up to a cashier in a grocery store. You have different numbers of oranges or apples. How much does this cost altogether? And they're going to do this calculation. It's going to be, you have 8 apples times $1 per apple. So that's going to be $8 plus 2 oranges at $2 per orange. That's going to be another $4. So you have to pay the cashier $12. So as you think about this, notice that the cost of the apples is not changing and the cost of the oranges are not changing. Those are 2 constants in this problem. They are not changing throughout the problem, and they shouldn't. If they were changing, that'd be really weird to try to figure out how much it costs. What does change is the number of apples you purchase and the number of oranges that you purchase. So that is changing. And you're going to see over here that there are 3 answers that are the same. That's going to have some meaning later on. So when do you spend the same amount of money? What combination of apples and oranges can you purchase to get to spend $12, for example? So we're going to look at that idea a little bit later. So then, actually moving towards that idea, what if Noah has $10 to spend? Can he buy 7 apples and 2 oranges? And the answer to that is no, he can't, because the apples are going to cost him $7, the oranges are going to cost him $4, and so he adds that cost together, it costs him $11. So no, it costs too much. So he can't buy 7 apples and 2 oranges. So that is not a combination that works. And so what we're going to say is that is not a solution to this problem. I need to buy a certain number of apples and a certain number of oranges. That equals $11. That is not a solution. All right, so now it says, what are combinations of apples and oranges that Noah can buy where he's going to spend all of his $10? So he has $10 to spend. He's going to spend all that $10. What are some combinations of apples and oranges that he can purchase? These are going to be called the solutions to the problem. So you buy a certain number of apples and you buy a certain number of oranges. That combination will be, and it equals $10. That combination will be a solution. So let's look at the first set of examples, and I'm going to just construct a table. That's really the only way you have to look at this right now, is to look at it in order by constructing a table. So just go through and list the number of apples purchased, 1, 2, 3, and figure out how much money you're spending. So how much money do you have left over so that you can spend a total of $10? Now something right away interesting pops out. So if I purchase 0 apples, I can buy 5 oranges. That's going to be spending my $10. And if I buy 2 apples, that's going to cost me $2. That means I have $8 left, so I can buy 4 oranges with that $8. So 4 times $2 is the 8. 8 plus 2 is the $10. But I cannot buy 1 apple and spend $10. If I buy 1 apple, then the amount of money I have left is $9. I can't buy number of oranges that's going to equal the $9. I can buy 4 oranges and that equals $8, and I can buy 5 oranges that equals $10. But since I'm always multiplying by $2, it's going to go up $2 every time. So it's going to jump over the $9 and go from $8 to $10. So let's just say I purchase 4 oranges, cost me $8. I'm going to end up spending $9. And likewise, if I buy 3 apples, I can't get to $10 because that's $3. I have left $7, but I can't. Every orange I purchase costs an even number of dollars. So 1 orange is $2, 2 oranges is $4, 3 oranges in this case is $6. So it's $2, $4, $6. So it jumps over the $10 because 4 oranges would be $8. 8 plus 3 would be $11. So there's something about this where the number of apples I purchase has to be an even number. If it's an odd number, it doesn't work. If an even number, it does work. So let's look at the rest of this and see if that's true. And I am going to just use an even number of apples. So 4, 6, 8, 10 apples. So that's $4, 6, 8, $10. And now I can always figure out an amount of the oranges, a number of oranges to purchase to get to $10, because that number of oranges gets multiplied by 2 to figure out the cost. So $2 times 3, $2 times 2, $2 times 1 is 2, 4, and $2 times 0 is 0, 2, 4, 6. So if you have an even cost of oranges, then to get to $10, which is an even number, you have to have an even cost of apples. Even cost of oranges, because they always get multiplied by 2, and you have to have an even cost of apples. So that means you have to purchase either 0, 2, 4, 6, 8, or 10 apples. The moment that you purchase an odd number of apples that costs an odd amount, you can't add an odd amount to an even number to get 10. Just try it. Try what's an odd number you can add to 8 to get to 10, or an odd number you can add to 6 to get to 10, or an odd number you can add to 4 to get to 10. You can't. You have to add an even number to the even cost for the oranges to get to $10. All right, so that fixes your possibilities to, and it says here, use 2 variables to write an equation that represents that $10. So now it's fixed. Every time you're going to spend $2 per orange and $1 per apple. So that's how you figured out how much it costs you at the cashier. So they looked at the number of apples, multiplied it by 1. Looked at the number of oranges, multiplied it by 2. Added them together, it equals $10. So the number of apples plus the number of oranges multiplied by 2, it's going to be, you're going to use that to figure out the cost, and it's going to equal $10. So the equation then becomes A, number of apples, plus R, the number of oranges. And we're using R so you don't get mixed up with the O and the 0. So we're using R for oranges. So the number of apples plus 2 times the number of oranges is going to equal $10. $2 per orange. So the cost is 2 times the number of oranges. Cost of the apples are the number of apples. It's $1 per apple. All right, so it says what are 3 combinations of apples and oranges that make your equation true? Well, I have 1, 2, 3, 4, 5, 6 combinations right here. And what are 3 combinations of apples and oranges that make it false? Well, we listed 2 of them. Whenever you have an odd number of apples, then it doesn't work. And so if I were to use 5 apples, for example, what numbers can I get to with 5 apples? That's $5. I could purchase 2 oranges. That's going to be another $4 to get me to $9. So that doesn't work. Or if I purchase 3 oranges, that's 3 times 2 is $6. $6 plus that $5 gets me to $11. So it jumps over the $10. So any odd number of apples does not work. So these do not work. $1 and $3. All right. So that's the end of the activity. And I'm going to make a couple of comments that hopefully will help in the next activity and throughout the rest of this lesson and this unit. And so what I want you to do is go back to this idea here and notice that the cost of the apples and the cost of the oranges are independent of each other. So when you go in and you look at the cost of the apples, it's not related at all to the cost of the oranges. So there are two constants in this case. One constant is $1 per apple, and the other constant is $2 per orange. Now this is different than the problems that we've done up to this point. The problems we've done up to this point, there is a dependence between the two properties. So for example, when running, the distance that you run depends on the time that you run. They are related by one constant. That's that constant of proportionality. So it's distance per amount of time. So there is a relationship there. There is a dependence. Whereas what we just looked at, there's an independence. There's not a relationship between the two costs, apples and oranges. Now, we did add the idea that you can spend exactly $10. So that is a constraint. That's something that's saying, okay, you have to add to this problem that you have to spend exactly $10. So now there is a dependence on each of these items, on the apples and the oranges, because as we saw in the table, if you buy 2 apples, then it defines the number of oranges you can purchase. And that's what we saw in the table, and up here, that's the same thing that we're seeing up here. Let's say that you have to spend that $12. So I decide to buy 4 apples. That means I have to purchase 4 oranges to get to that $12. Same idea down here. So now we're defining it. We're saying you have to spend that $10. Once you define how much you can spend, now the number of apples and the number of oranges are dependent on each other. What that means is now we can write an equation, and that's what we wrote actually right here. A plus 2r equals, it's right here. A plus 2r equals 10. So now we can write an equation. What that means in the future is, because it's an equation, you can draw a graph of that, and because this is a linear relationship, that graph will be a straight line. And finally, what that means is you can actually rewrite this equation right here in this form, y equals mx plus b, and start looking at the slope and where it crosses the y-axis. This is a little bit farther down. And I do want to pick up on this idea just for a moment, and this is really getting beyond the scope of this lesson. I'm just going to throw it out there because it helps me think about where we're going in the future. So if I take this equation right here, a plus 2r equals 10, so now we're moving away from the context, but it was the cost of the apple plus the cost of the oranges. Those costs combined equals $10. And I'm going to say that the apples are going to become x and the oranges are going to become y. So this is the new equation using x and y. So x plus 2y equals 10. You're going to see in the next activity that the equation that you're going to work with is actually going to be 2x plus y equals 10. So this is very similar to what we are going to do next. But you're not going to do this down here. And I'm just going to take you through this and show you that you can now rewrite this equation in this form down here, y equals mx plus b. And you guys are to the point where you can start to see this fairly easily. If I have 2y, I want to move this x over to this side of the equation. That means I can subtract this x. And so 10 minus this x, and it's going to be a lot easier for you if you rewrite this using the inverse operation, which is addition. So instead of 10 minus x, we use the inverse operation of addition and the additive inverse, the additive inverse of a negative 1. So I'm going to add a negative x, which is negative 1 times x. Sorry, I messed that up a little bit. But you can rewrite 10 minus x as 10 plus a negative x, or negative 1 times x. All right, so now you can just divide through. Now I have two groups of these things. So 2y equals 10 and a negative 1x. So I have two of these things, and I want to divide them up into a single group. So I want to divide them by 2. So if I have now just 1y, that means I have to take this 10, divide it into 2. So I'm going to end up with 5 in each group, and I'm going to take this negative 1, divide that by 2. So it's going to be a negative 1/2 in each group. So it's going to be a negative 1/2 x plus 5. So now we're down to this point. Sorry about this. So y equals, and you can rearrange this using the commutative property. So this is a negative 1/2 x plus 5. So now this is in this format, and I'm not sure where we're going to go with this, but I just want to show you and make it, try to get it into your head as a way of thinking about these problems. So now if I write this form up here and just compare them, I can move the 1/2 x back over here by adding. I'm going to add 1/2 x, which gets rid of this, a negative 1/2 x plus a positive 1/2 x means this equals 0. So now I have 1/2 x plus y equals 5. And notice how this compares to this equation. X plus 2y equals 10, and 1/2 x plus y equals 5. Well, if I multiply each of these by 2, 1/2 times 2 is x. 1y times 2 is 2y, and 5 times 2 is 10. I get this equation over here, and if I divide each of these by 1/2, this is 1/2 x plus y equals 5, and I get this equation back over here. It's probably too much. I just wanted to put it somewhere, and I don't know if we'll return to it or not right now.